In this problem, we're asked what value of x is the curvature for y equals e to the x smallest. And we know that the equation for curvature is supposed to be absolute value of y double prime divided by 1 plus y prime squared and then 3 over 2. But it's kind of cool because for y equals e to the x, let's figure out what y prime is. That's just e to the x. And what y double prime is also e to the x. So it turns out that it doesn't really matter what these y's are. So we can rewrite this equation kind of like y over, I'll make this, I guess, the square root of 1 plus y squared to the third. It's kind of like that. And we also know that the radius is supposed to be 1 over k. So we can kind of flip that, and because we're looking for the radius. So it's actually just the square root of 1 plus y squared to the third divided by y, the absolute value. And if we want to figure out what the smallest value of this x is, which is here, then that means that we need to set the derivative of this equal to 0. That's because we're going to have this kind of a curve like this, and we're thinking to ourselves, okay, we want to know when is that the smallest. So it's going to do something like this, right? We don't really know exactly what the curve is going to look like, but we're trying to figure out, like, you know, the bottom point right there. So we just need to figure out what the derivative is, set that equal to 0, and then we should be able to find our smallest point. So let's take the derivative of r on both sides with respect to y. And the derivative of all this is just going to be 2y squared minus 1 square root of 1 plus y squared. And then divide that by y squared. Not going to go too crazy on the calculations there because it's kind of ridiculous. But anyway, we're going to set this equal to 0. And because that's equal to 0, I mean, this doesn't matter. We just want the top equal to 0. So we focus on this. So we say 2y squared minus 1. And in fact, let's expand that out a little bit. So 2y squared times 1 plus y squared minus the square root of 1 plus y squared. That's supposed to be equal to 0, so we could set them equal to each other. Divide out the 1 plus y squared on both sides. You're going to get 2y squared equals 1, and then y squared equals 1/2, and then y is equal to 1 over the square root of 2. And so that is what e to the x is equal to. So if e to the x is equal to 1 over the square root of 2, we take the ln on both sides, and so we get that the ln of 1 over the square root of 2 is equal to x. Okay, we're close, because we can also rewrite this and say that the ln of 1 minus the ln of square root of 2 is equal to x. And so therefore, x is equal to negative ln of square root of 2. And that will be the smallest x value. Interesting.